been an awakening. Have you felt it? Imagine a world where you can have a lightsaber with dynamic sound. That is essentially what the project that we are doing for this for the senior design. So what I'm going to do is we're actually going to introduce ourselves. My name is Garrett Stoss. First off, we're going to do Miss Kristen Velmans. She is actually lead in communication. She also played a major part in finding parts, as well as played a major role in creating the PCB and layout. We also have Sabrina Thompson, who was actually in charge of the different organization, as well as the different paperwork, as well as helping Kristen with the microcontroller code as well. We have Ms. Haley McCurry, who also was the lead of the PCB and layout design. And finally, my name is Garrett Stoss. I was in charge of audio engineering, as well as creating the pseudocode for the audio dynamic sounds. We originally started this project given a circuit board given by Mr. Parks themselves, who actually we ended up redesigning the board because it actually ended up not having the necessary tools that we needed for the different parts. We found that many of the different parts did not meet the necessary specifications that were bearing on the sound. We ended up using the Arduino Wave Shield as the original microcontroller, and then would eventually convert that code into the MSP430, which had a little bit more processing power than we needed in order to do the different pitch shifts and frequency shifts that we originally planned. We would use a pitch matrix that would actually be able to be used as a way to find the different positions that the blade can actually be positioned at. So we're using an accelerometer as well as a gyroscope to not only determine speed, but also orientation of the blade as well. That way, when you would be able to hold it in a different position, you would be able to use the different effects to mirror that position. We used the PCB that we actually created this semester. We're unfinished. It's unfinished at this point, but we hope to have it done before the next semester starts. We are using necessary components such as the accelerometers, voltage regulator, as well as the gyroscope to push enough current into the 96 different LEDs that make the blade and light it up. Finally, we actually have our main goal this semester was actually to create the PCB and get the pseudocode ready for it. We have a stretch goal for next semester, so if we end up actually finishing this project, we'll be able to have it done by May and be ready to ship out for customers. We also, the stretch goal for us is actually, if we do finish it, we want to be able to design a circuit that would use a different LED, which actually would be a less expensive cost to the customer for a little bit more, less audio and less dynamic for the customer initially. Thank you for your time. Are there any questions?
I had one quick clarification. So, Parks, Sabers, the company?
Yes.
Those things? Okay.
Yes.
And so what's of what you have here, what do they manufacture? Do they manufacture the hand?
Define they, you mean
Parks,
Sabers?
I'm sorry, yeah.
Park Sabers actually ships most of their manufacturing out to China. So we have to create these PCBs in a way that we be able to account for the greater design, the more limiting design specs that they have over in China. So they do not do production in-house, they do outsourcing.
Okay, but Parks is currently producing a lightsaber today. It just simply doesn't have sound effects.
Mm-hmm.
Okay.
And we will have 2 of those blades that do not have sound effects that are currently in production at our display table.
Okay. Great.
Yes.
So you mentioned accelerometer and MSP430. So on your PCB, how was the electronics interacting? And or is that a design that came from the company? How are you interacting the accelerometer and sending your data to the MSP430, which I'm assuming is part of the PCB?
Yeah, so we're using the MSP430 is kind of our central brain to the whole system, and then we're using I2C to communicate with the accelerometer. We may have 1 or 2. We have to still do some exploring on our design. Hence, we have a very modular development board developed that we'll have an example of at our table. But we're pulling data from the accelerometer to determine how fast our blade is moving, and pulling data from the gyroscope to determine what orientation it's being held at. And using that information to determine where in our frequency matrix we need to be, whether we need to be at a higher frequency or if we need to be at a lower.
So the accelerometer was chosen by them?
Yes.
Okay.
Does it all fit to
Right.
or will it be external?
Eventually, we want to be able to minimize the
conclusion. So